when it comes to rectilinear motions, motions of a moving object, we want to make use of the fact that if you have a position of a moving object at time t, what's the meaning of the derivative? Derivative is the velocity. And if you take the derivative of the velocity, what do you get? Acceleration. That's the core idea of this solution. You just have to remember that if you differentiate the position, you get the velocity, because derivative is a rate of change, and rate of change, the measure of how fast the position changes with respect to time, the rate of change is really the velocity, right? And what is acceleration? It measures how fast the velocity changes. That's why it's the derivative of the velocity. Okay? So if you remember that derivative means rate of change, these two facts are kind of natural. Okay? All right, so let's differentiate. If you differentiate once, that's negative 32t plus 64. If you differentiate twice, that's negative 32. So that's the velocity and the acceleration. Okay? Now let's go through each question. A, what's the velocity at t equal to 1? How do you answer that? Since we have the velocity at each time, each moment in time t, we just have to plug in 1 into the function t, vt, and I get negative 32 times 1 plus 64, which is 32. And then what is the maximum height of the ball? Max height. This you need some imagination. What happens? Yes?
Acceleration is 0?
No.
Velocity is 0.
Velocity is 0, yes. So if you throw something, and at the moment it reaches the top, briefly it changes from positive velocity to negative velocity. So, and therefore, at the moment when it's at the top, what's the value of the velocity? If you want to go from positive to negative, it must be 0 there, right? So the max height of the, if you want to know the max height of the ball, you first look for the time when it hits 0. So we have the velocity negative 32t plus 64. I'm looking for the time when this velocity becomes 0, and the solution is 2. If I move this over there and divide, I get t equals to 2 as the time. And therefore, to get the maximum height, you just plug this number into there, and you get h of 2 equals to negative 16 times 2 squared plus 64 times 2 plus 80, and that will be 140. And by the way, these questions come with all kinds of units, so we should really write that in the units. This is really feet per second, and this is feet. Now C, when does the ball hit ground? Time ball hits ground. Now this question has nothing to do with calculus at all. It's actually a pre-calculus question. How do you solve this? Ground means height is 0. So you just have to look for the time when the height is equal to 0. Now let's divide everything by negative 16. So you get 0 equals to t squared minus 4t plus minus 5. I can factor this as t minus 5, t plus 1 equal to 0. So you get t equals to 5 or negative 1. Okay. However, can you have negative time? No, we're only thinking of the moment after we throw the ball. So t equal to 5. 5 seconds will be the answer for this. The answer is 5 seconds. Now D, find the impact velocity. How do you find the impact velocity? What does impact velocity mean?
Speed on it.
It's the velocity when it hits the ground, right? When it impacts the ground, right? So how do you do that?
Well,
velocity when the time is 5?
You just want to know the velocity when time is 5, right? And you plug 5 in here, you negative 32 times 5 plus 64, which is negative 160, negative 96 feet per second. Okay, and actually, I think of all the questions that's in this problem, question E is the one that students get wrong the most. So find average velocity from time t equals to 2 to time of impact. Let's think about this question. What's the difference between average velocity and instantaneous velocity? Average velocity is the velocity over a time period. Instantaneous velocity is the velocity at each moment. Okay? Which one is the derivative? Instantaneous or average?
Instantaneous.
Instantaneous velocity is the derivative. Okay, so when they're asking for average velocity, they're not asking for instantaneous velocity. So what is the instantaneous velocity? It's dh dt. It's at some moment in time, in very short duration, you want to know the change in the position and you want to know the ratio. That is the derivative. Okay. How is this defined? This is defined as limit of delta t going to 0 of delta h over delta t. That was the theoretical thing that I explained a long time ago. This is for some, not short period, but for some period in time t, if you measure the change in h over change of t, that gives you the slope during time interval. Right? That's what we call the slope of the secant. Okay? And when you decrease this window, delta t down to 0, that's what we call the instantaneous velocity. Right? So when you call the average velocity, it's really talking about this one without the limit. You get that? That's what it is. Okay? So we have to compute this from t equals to 2, and the time of impact is t equals to 5. So we have to figure out delta h and delta t from t equals to 2 to t equals to 5. Right? That's what we need to do. So let's do that. So erase all that because we need, so solution to this is because we need change of h over change of t, we have to know what was the height at time 5 minus what was the height at time t equals to 2 divided by 5 minus 2. All right, what was the height at 5? Isn't this the impact? Time of impact? Right, so 0. Okay, what was the height at 2? 144. Divided by 5 minus 2, which is 3. Okay. So that gives you negative 48. So that's called the average velocity.